In this lecture, we are going to solve some 2D problems. So what happens in real world, everything is 3D. There is no such thing as 2D bodies. But there are some problems that can be simplified and then they can be simulated in the 2D space rather than the 3D space. Because 2D simulation models will help us to handle the simulations much better. We can generate a better mesh quality and solving time will be lesser in comparison to 3D. So coming to this particular problem, here we have a rack as well as a gear. So what we are going to do is we are going to take this as a plain problem stress and we are going to solve this particular problem. So here the main aim of the problem is we are designing a press that you can see in the diagram. Press should be capable of delivering a 2500 Newton force at a position 1 of the rack. So what happens in order to design this particular mechanism, we are going to apply the load at the position 1 of the rack and we are going to fix the gear and we are going to find out how much momentum is required to be applied in the gear at here so that the force at the rack will be around 2500 newtons. That is the first case. And coming to the second case, what we are going to do is instead of viewing the force at rack, we will fix this particular position and then we are going to apply some momentum value at gear and try to find out what is the force value that is being generated at rack for the moment value that has been applied to gear. We are going to perform all of these things in Ansys workbench and we are going to perform the analysis in 2 dimensions. In order to perform analysis on the gear and rack, I have opened Ansys workbench. So once I open Ansys workbench, set up the static structure, drag it and drop it on the project schematic. And once I have done that, I can just give out the engineering material, but here according to the problem specification, both the gear and rack are prepared with structural steel. So leave it to default. Now what I'm going to do is before you go and import the geometry, you need to right click on the geometry cell and you need to select this particular properties option. So what happens if you select this properties option, number of options will be appearing here. Now select geometry option again and from advanced geometry option, change analysis type to 2D from 3D. So once I have changed this analysis type from 3D to 2D, then only you need to import your geometry. Now right click and say import geometry and select your model. Now right click on model cell and select edit. And here is our 2D model on which we are going to perform analysis. The first thing you need to do is you need to edit the thickness of gear and rack. So in order to edit the thickness of the object, you need to expand this geometry tab or group. I am going to just click on the gear and here the thickness is assumed to be 1000 mm. But according to the problem, it is only 12 mm. So I am going to just type in 12 mm. Now I am going to select the rack and then in the rack, also I am going to give the thickness of 12. So once I have given the thickness, now what I need to do is I need to create a remote point base upon which I can apply boundary condition. So in order to create a remote point, you need to select the model branch and in the model branch, you will have an option called as a remote point. So I'm going to select this remote point. And once I have selected this particular remote point, it will ask me the geometry at which there will be a remote point created. So I'm going to select this inner circle and then press apply here. The flag is showing the position of the remote point. Why I have selected the remote point? Because here we are going to apply the remote displacement. So what is the difference between normal displacement as well as remote displacement? In remote displacement, we will get access to rotational degrees of freedom as well as here we need to fix the rotational degree of freedom of the gear so that the gear is going to remain still. Because in first case, we are going to fix the rotational degree of freedom of the gear. So for that purpose, I have created a remote point. Then coming to the connections, select this contact region. We need to change as I told you that by default, say the behavior is selected at the bonded, but we need to change it to from bonded to no separation. Select no separation. So once I have selected this no separation, now what I am going to do is I am just going to right click and say mesh. So once the meshing is done, then we are going to apply the boundary conditions. Then we are going to calculate required results. In order to apply boundary conditions, I am going to right click on the static structure, say insert. And I am going to select the frictionless support. And I am going to select this particular edge. And I am going to apply the frictionless support. So what happens? when I apply the frictionless support, this particular rack will not be moving in this direction. It can only move in this particular direction. So once I have done this thing, I need to apply the forces. So for that purpose, I am going to right click on the static structure, say insert, and I am going to apply force. So once I select the force, I am going to select this particular edge and I am going to apply the force. So instead of the vector, I am going to change it to components, and in the components I am going to give 2500 Newton, because according to the problem, that is force which has to be generated by this particular rack, so I have given 2500 Newtons. Again, I am going to right click on static structural, say insert, and I am going to remote displacement. And once I select the remote displacement, there are different scoping methods. From the scoping, and I am going to select remote point option instead of geometric selection. And there is only one remote point which I have created. So in the remote points, I can select only that particular point. I just click on the drop down arrow and I am going to select the same point which I have created earlier. So once I have done this, here is asking me what are the components that are free and what are the components that are fixed. So here I am going to fix every component so that the gear cannot move and rotate. Now what we need to do is we need to view the results. For that purpose, what I am going to do is I am going to right click on the solution, say insert, and then I am going to see the total deformation. Now what I need to do is I need to find out how much momentum has to be applied at this particular surface to get a force of 2500 Newtons at this phase. For that, what I am going to do is I am going to go to the solution. I am going to say insert. In the insert, I am going to go to the probe tool. In the probe tool, I am going to say I want moment. So I want to select the moment reaction. And now once we have selected the moment reaction, we need to be specify at which boundary condition we want this momentum to be calculated. So go to this location method drop down and select remote point, because remote point is the boundary conditions where we want the momentum to be calculated. So I have selected this remote displacement support, and once I am satisfied with that, I am going to solve the problem. Now select total deformation, and here you will find the values of deformation which is generated. The maximum deformation value is 0.016 mm. Now select moment reaction, and in the details window down here, you can clearly see the value of momentum is 92,229 Newton millimeter. So our stated goal was to determine the required momentum that must be applied to the gear in order to produce a 2500 Newtons force in the rack. And here from the computer, we are able to calculate the required momentum to be 92,229 Newton millimeter. So the total approximate moment of the torque that is required was around 92,229. So now in the next case, what we are going to do is instead of applying force here, we are going to apply 92,229 Newton millimeter moment here, and then find out what is the force that is going to be generated at this particular face of the rack. I can just right click on this or click on the drop down arrow here, and I can say duplicate. So if I say duplicate, what happens to geometry? Engineering data, everything. The whole analysis system will be duplicated as a new one. In that, we can change a little settings and then we can perform the new analysis instead of taking the static structure and bringing it into project schematic again, and then recreating and every step of this particular process. So once the analysis system has been duplicated, I am going to right click on model cell and say edit. So after opening the Ansys mechanical module once again, so here we need to change some boundary conditions before we calculate the total problem. First, right click on this force and say delete. Now the first condition you need to select is this remote displacement, because what happens when we apply momentum here, what happens, this is going to turn, and this turn should be able to create force on the rack. For that purpose, I am going to free up this particular rotation, and here you need to free up this rotation. So I have freed up this particular rotation. So the next thing you need to do is you need to right click, say insert, and you need to select the moment. So once you go for the moment, it will ask for the geometry. So in the scoping method, select remote point, and from the remote points, you select the user as remote point. And now apply moment magnitude as 92,229 Newton millimeter. Then coming to this particular rack, so I am going to right click and say insert. Then select fix support. We need to fix this particular surface. Select it and I am going to press apply. Now delete this moment reaction. Now I am going to add a force reaction instead of a momentum reaction. I am going to add a force reaction. Say insert. Say go to probe and select this force reaction instead of moment reaction. And once you have done this, you need to give at which boundary condition you want to find out the force reaction. We want to find out the force reaction at this particular edge. So I am going to select the fixed support boundary condition. So once I have done setting up the analysis, now I am going to solve the problem. So once I solve this particular problem, I am going to check the force reaction probe and the value that occurred at the force reaction probe. Now see here, this is the total force reaction that occurred at the fixed rack when we apply moment of 92,229 Newton millimeter at gear. So this was our second required condition.